Welcome everyone to the 7th part in this video tutorial series about the OpenTK library. So in the previous part we had this result. We worked with lighting and this was the result that we had in the previous video tutorial. So now we're going to work with texturing, or you can call it texture mapping. So I'm going to give you a brief description about what a texture is. So a texture is basically image or image data or pixel data that you can use to map onto a primitive that you draw in your in OpenGL. Like you can draw a square and you can have an image mapped onto it, so that is a texture. There I've downloaded this image of one face of a wooden crate. So I'll create a cube and map this image onto each face of the cube, and that'll make the cube look like look like a real life wooden crate. So this is how texture mapping works. You use images to make your objects in your application look lifelike. So here's an image of a texture mapped onto a rectangle which appears as a wall. So you have to adjust the texture coordinates accordingly, which is specified to them, to make the texture look best. So like this one here, this is the texture mapped onto a rectangle. This is just a rectangle, and image of the wooden bricks is mapped onto it, and this makes the rectangle look like a wooden ball, brick wall. So this is how the texture mapping works, and now we'll learn about the basics of texture. So let's suppose this is our image right here. We'll use this image as texture. So it has a tree drawn on it. So every texture has coordinates, so although those are same for all the textures, but now we'll see how the coordinates are managed. So a texture has S and P coordinates, like the XY coordinates for a coordinate system, or some applications also use the UV coordinates. But OpenGL uses S and P, so we'll use these. So this is the 0, 0 point. So S is 0 and P is 0, 0, 0, and the maximum width of the texture, no matter how high resolution your image is always 1. So width is 1 and height is also 1, but at this point will be 1, 0, and similarly this point will be 1, 1, and this will be 1, 0. So this is when you load an image as a texture to your application. This is the default coordinates of the texture. And now let's suppose you have your OpenGL and you want to map this texture onto a primitive, which is like this. This is our primitive. This is a quadrilateral. So we want to map this tree texture onto this primitive. So what we'll do is when we specify each of the vertex, like we specify this vertex is 0, 0, 0 in the OpenGL. Before that, we need to set the current texture coordinates. So if you have already loaded and binded this texture as a current texture, and then you can specify the texture coordinate as 0, 0, and then specify this vertex. So this vertex will be assigned this coordinate. Similarly, now you'll specify 1, 0 as the texture coordinate, and then you'll add this vertex. So this vertex will correspond to this. And similarly you'll do this for the remaining vertices, and these will be the corresponding vertices of the texture to the vertices of the our primitive. So the tree texture will be mapped onto it like this. And if you want to repeat your texture, which is the by default how it works, like if you specify this coordinate if you specify the texture coordinate as 2, 0 before specifying this vertex, so the texture coordinate is 2, 0, but the maximum width of the texture is 1. So what will happen here is 1 lies here. So this is the width of the texture. So and you also specify the texture coordinate for this vertex as this will be 2, 1. Yes, you specify the texture coordinate for this vertex as 2, 1. So this is how the texture will be mapped onto it. The texture will be stretched along the y-axis, and this will be how it will be drawn. So there will be 2 trees drawn now because this texture coordinate is 2. So 1 corresponds to this. So this is a single texture here. And if you specify the y coordinates also as 2, you'll have 4 textures now, 4 trees, one here, one here, one here, and one here. So this is how you can scale the texture. You can have multiple images of the texture on the primitive. So this is actually what is used here. So if you only have an image of a small portion of the bricks, you can actually use that same texture, which will repeat over and over again to fill a bigger quadrilateral. So now we'll start with practical. Now we'll start with the practical stuff, and we'll do the texture mapping in the API. So we'll first go to the loaded function, which is called whenever the window is loaded. So we enabled lighting and we did all the lighting stuff from this function. So we'll also do the texturing stuff from here, because the texturing needs to be enabled and to be specified whenever the application is started. So I'll use the enable function, because just like you enable the lighting, enable cap.lighting, you also need to enable texturing. So enable cap.texture 2D. We are only using the two-dimensional textures, although one-dimensional textures can also be used to specify the colors or the materials for lines, but we're only going to work with the 2D primitives. So we'll enable the texture 2D. Now we've enabled the texture 2D, we need a texture variable, a texture object. So what is texture object? It is the object that stores a name for the texture, which has all of the data about the texture. So texture object is actually an integer. So I'll go into the global scope at the top of our program, and I'll declare a new integer texture. So this will act as a texture object. So a texture, we need to assign a unique texture name which has not been used earlier to this texture variable, and that will store the memory address of our texture data, the data about this texture, all of the information about this texture. So this int texture is the texture object. Now we'll go back into the loaded function. Down here we need to assign a unique name to it, to the texture object. So for that we use gl gen textures. So this function, what this function does is that it returns a new texture name which has not been used into the texture which is specified as the argument. So first argument is an integer which specifies how many texture objects, how many texture names you need to generate. So we only need one texture name, and second argument is the variable into which the generated texture names are to be returned. So that are to be returned in the texture variable, but since it has to be returned into the texture variable, you need to use the out keyword here, because the data will be returned into this variable. So we have generated the texture, and next thing we need to do is we need to bind the texture before we begin assigning image data to it. So we'll use gl dot bind texture for that. So we need to bind the current texture. So first argument is the texture target dot texture 2D. So target is 2D, and the next argument is the texture object which we need to bind currently. So which is texture. Texture. So we have binded this texture object now. So that means that whatever image data we specify will be added to this texture, and whenever we use the texture coordinates, this will be the texture we will be using. So this is what binding means. You can also unbind a texture by passing 0 as the second argument. This will unbind the texture which has been specified currently. So where this binding works is that you have multiple texture objects, and you can bind one texture object and draw primitives using that object, and you can bind the other texture object and you can draw primitives using that. So we have binded this texture, and now we'll load the image data into it using the gl dot text image 2D. And now, but the problem is that we do not have any image data. So now we'll look at our image. So I have downloaded this image from the internet. Although you can choose any image you want, but always try to keep it as a square. So this has x coordinate equal to y width equal to height. So now I'll save this. Now you need to take care of the format. You need to know the format in which your image is in. Although C# supports many formats, but the one we're going to use here will be so we'll use 24-bit bitmap. So we'll save it as 24-bit bitmap and we'll name it crate.bmp. And now I'll save it 24-bit bitmap. We're going to use this format. So I've saved this image. You didn't see the location. I've saved this in the F drive. So you need to know the location, the path for your image where you have saved the image. Although you might want to do save it in the directory of your executable, you can do that. But you need to remember the path for the image. Although you can also use relative path or whatever you want. So now we need to load the image. So we need to do that before we use this function. So we'll just keep it as it is here. And now we'll go at the bottom of our program and define a new function which is called load image, and it'll take an argument which will be the path of the image to be loaded. So we'll call this string file path. So this will be passed when the function is called. So we'll load the image which is present at this file path. So it'll now, after loading the image, it'll return the bitmap data. So system.drawing.imaging.bitmap data. So this is actually the pixel data or the bitmap data which contains the data about of the image. So this is basically the image data which we need to specify the texture image. So it'll return bitmap data. So now we need to first load the image before we begin loading the bitmap data, because we'll first load the bitmap and then we'll read the bitmap data from the bitmap. So system.drawing.bitmap, we'll use this thing and we'll call the variable bmp equal to new system.drawing.bitmap, and it takes the argument which is the file path, the name of the file which has been passed into this function. So the image will be loaded from this path. And now that we have the image, we need to extract the bitmap data from it. So system.drawing.imaging.bitmap data, bmp data, equal to new. Now to extract the bitmap data, you need to use bmp.lockbits function. And it takes 3 arguments. The first one is the rectangle. So it's the rectangle from where you want to load the images. So this specifies the coordinates of the bitmap, which will specify a rectangle, and all the image data inside that rectangle will be loaded into the bitmap data. So lockbits function actually locks the data into the memory, and it also returns the data. So we'll store the data inside this bitmap data variable. So first we need a rectangle for that. So system.drawing.rectangle, rect equal to new system.drawing.rectangle, and it takes 4 arguments. The first one is the x and y position. So we need to specify a rectangle. So this is the same. We need to specify the rectangle in accordance with the Windows coordinates. So that is 0, 0, this bitmap dot width and bitmap dot height. So this means the rectangle will cover all of the image. So the whole of the image will be loaded when we specify use this rectangle to lock the bits. So we'll use this rectangle rect comma, and the next argument is image lock mode. So it goes system dot drawing dot imaging dot it is image lock mode dot imaging dot image lock mode dot read only. We only need the read only access because we are not writing anything to it. And the next argument is the pixel format, the format of the image that we are loading, which is RG, which is okay. I'll just specify whole of it here. System dot drawing dot imaging dot pixel format dot, and now we need to choose a suitable format. So we had 24-bit bitmap, so the format for that is format 24 bpp RGB. So this will be our format for this, because this is the format of the image that we saved. We saved the image as 24-bit bitmap. So whenever you want to use an image in your application, you need to save that to the format you want to use here. So you need to know the format in which your image is in. And so we have the locked bit inside the bitmap data. So once we have the data, now we can unlock the bits. BMP dot unlock bits. So BMP data, so we can free the bits from the memory because we have saved them in the bitmap data, and now we'll return the bitmap data. So this will be returned from this function. So what this function does is it reads the bitmap data from the location sent into it, and it returns that. So now we'll go back into a loaded function, and from where we were enabling texturing, and now I'll create a new bitmap data variable here, system.drawing.imaging.bitmap data. So text data equal to, and the function call was load image and the path of the image. So you might want to use the @ prefix to, if you want to use this character inside it. So I saved my image at this path dash create.bmp. So that's why we need to know the path of our image. So this image will be loaded, and now we have this image in the texture data. We can begin specifying the texture. So text image 2D, so the first argument is texture target, which is texture 2D. We also used this earlier. And the next is the level argument, is the level, will always keep it 0, and then the argument is pixel internal format. So it's part of the OpenTK library. So OpenTK dot graphics dot OpenGL dot what was the argument? Pixel internal format dot so this is actually the format of the texture. We are in the RGB mode, and we'll use the RGB as the format of the texture because we have not studied about the alpha value, the A. So we'll just use the RGB, and then next argument is the width of the texture data. So if you want, now you need to know how to get the width. So this is actually the member of the texture data variable. So text data, this is our variable. Oops. So text data dot width, and the next argument will be text data dot height, and the next argument here is the border. So it will have no border. I'll go into the next line, comma, border will be 0, and the next argument is pixel format. So this is the format of the format in which the image has been loaded. So a bitmap has format of BGR. It does not have RGB format, it has BGR, blue, green and red. So we need to specify that. So that is OpenTK dot graphics dot OpenGL dot pixel format dot BGR. So BGR is the internal format for this, and the next argument is the pixel type. So that the data and the bit from the bitmap is loaded in the form of unsigned bytes. So pixel type dot unsigned byte, and the next argument is the pointer to the pixels. So this is actually returned by the member of text data, member of the bitmap data, which is scan0. So this returns all the pixel data. So we need to use this as the last argument. So this is the actual pixel data which has been stored inside the image. This is the data of the image. So now we have our image. So this data has been so the texture object, this object contains this data. So whenever we bind this texture and draw a primitive using this will be mapped onto it. And now the last thing we need to do is we need to build MIP maps, so which is done through gl dot generate MIP map, and it takes the argument target, which is generate MIP map target dot texture 2d. So now I'll show you what a MIP map means. So a MIP map is actually a map of the image which contains the image in various sizes. Like this is the actual image of our tree. So when we call the build bitmap function, it generates smaller image of the same texture, so that whenever we create a smaller primitive and map the texture onto it, it does not have to do many calculation to scale the size of the texture. So it already has the smaller images like this. So many smaller images of the same tree. This is what the build bitmap function does, and we'll now have this MIP map built, and we can use this MIP map now. The OpenGL will use this MIP map itself to map the textures onto the primitives. So in OpenGL, when we use through C++, you necessarily do not need to call this function, but OpenTK requires a call to this function before you begin to use any texture. Now we'll begin specifying the texture coordinates. So I told you how a texture coordinate corresponds to a vertex this way. So we need to apply this here now. So when we specify this vertex, if we look at it, it is actually the bottom left vertex. So we need the bottom left texture coordinates. So gl dot text coord 2 function is used to specify texture coordinate in the format of s and t. I told you the coordinates were sp, but it's not actually p, it's t, s and t coordinates. So s and t. So the first coordinate, the bottom left corner, is 0, 0. Similarly, this vertex is the bottom right. This vertex is bottom left. So we specify this as texture coordinate, and this coordinate will be assigned to this vertex. And the next coordinate we'll need to specify will be of the bottom right, because this vertex is the bottom right. So this texture should correspond to the same. So bottom right, and the next vertex correspond to top right, which is 1, 1, and the next correspond to top left, which is 0, 1. So this will build the texture. This will map the texture onto this face, the front, only the front face, because for the rest of the faces we have not yet specified the texture. And now we'll build and run the application and see if this works. There it goes, but it appears a bit red because this is because of the lighting. The calculations done by OpenGL also include the stuff done by the lighting. So this is our texture right here, but it has some effect of the lighting. So we'll first turn the color of the light to white. So that'll only make the color of the texture come out. So this is the color of the diffuse light. I'll set it to white, and also the ambient light, I'll set it to white too. So now I'll build and run the application and check if this is working. There we go. We have, it'll come around again. So we have a texture of the wooden crate onto one face of a cube. So this looks like a wooden crate, and now what you can do is specify all of the texture coordinates for all of the vertices right here. So I have them done in this text file. So I'll just copy this content from here, and I'll paste this in place of this. So I've already specified the texture coordinate. It takes a lot of time, and so this cube has the texture coordinate specified to all of its vertices. So now if we build and run this, we'll get this, a fully textured cube, and this looks like a wooden crate. And now you can use texturing in your application to make it look more real. And I told you how the texture you can display more than one texture images on one primitive. I'll specify this as 2 and 2, 2. So this will make 4 images on one face. It'll come around again. So there were 4 images of this crate on the front face. So you can see there. Oops, it went away again. Okay, just leave it. So this is how texturing works. But although this was just some basic texture mapping is a very vast topic. You have various other concepts on it here too. And similarly, you can load multiple textures, and now you can use the bind texture function to bind to a specific texture, and then you use that texture to a texture coordinate, so that you can load multiple textures by this function. And when you want to use this, you can use the bind function before you begin specifying the texture coordinates. Although here I'm not using the bind function because we have already binded that, but you might want might consider using the bind texture function, calling this function each time with the specified texture object to avoid any unexpected results. So I set the current texture to this using the bind texture function, then I can set the current texture to any other texture and draw the same primitive again with the different texture. So you might want to consider using this function every time before you begin specifying the texture coordinates. Although we'll learn more about texture mapping, and we'll practice this more in the upcoming video tutorials. And the last thing I want to tell you is that you're not limited to square primitives. Like, you have a triangle primitive here, you can also map this texture onto triangle primitive. You can only specify 3 texture coordinates. Only 3 texture coordinates, like this and this. So this will correspond to only half of the texture, so this will be a triangle. This will be how the texture will be mapped onto this triangle. So that was all about some basic texture mapping, and I'll see you in next time.